we've got is an example of a projectile launched horizontally, and what we've got is a person standing at the edge of a cliff, kicks a stone over the edge of the cliff with a horizontal speed of 15, or horizontal velocity of 16 meters per second. If the cliff is 54 meters high, uh, how far from the base of the cliff does the stone land? We also want to know with what speed does the stone strike the water. Let's start out with how far away does the cliff, how far away from the base of the cliff does the stone land? We'll work with that. We've got a little picture here. Essentially, we've got the cliff, which is 54, 54 meters high. And we want to know how far out it lands, this horizontal change in position. Let's go ahead and fill in our table. Horizontal change in position is our question mark. In other words, how far away from the base of the cliff does it land? Vertical, we've got 54 meter high cliff. The original in the vertical direction is going to be 0 because initially in this direction, as it's sitting on the cliff, in the vertical direction as it's sitting on the cliff, there is no velocity. It's not moving up or down. Horizontally, it's kicked with a velocity of 16 meters per second. V final for the vertical, we don't know. We're asked what speed it strikes the water with. We'll talk about that in a little bit. Let's get part A done first. Horizontally, V final, since there is no acceleration in the x direction, in the horizontal direction, this is still 16 meters per second. Acceleration here is 0. Time is going to be the same for both. And acceleration in the vertical is negative 9.8 meters per second squared. There is no acceleration because remember, once this stone leaves the cliff, once that foot stops giving it a kick, there is no force that causes it to accelerate. We're going to ignore air resistance, which means there's also no force that causes it to slow down. So there is no acceleration in the horizontal direction. All right, let's go ahead and get started on our problem. We're going to take a look at the horizontal direction first, since that's what we need. We want to know how far away it lands. So in the horizontal direction, we want to know a change in position, so we'll try this equation here. Change in position is equal to V0t plus 1/2 AT squared. In the horizontal direction, we're looking for change in position. V0 is 16 meters per second. We don't know time. 1/2 times the acceleration, which is 0, times the time squared, which we don't know. That's all going to drop out because 0 times anything is 0. So this all goes away because 0 times anything is 0. So 1/2 times 0 times t squared, done. What we find is that we're still missing time. So we're going to try to go over into the vertical direction and see if we can find time. So vertical, in the vertical direction, the equation that has time in it and change in position, because we have it, is still change in position is equal to V0t plus 1/2 AT squared. We're going to find that this is probably the most useful projectile equation out there. Occasionally we'll use the others. This is what we're going to use most of the time. So change in position is going to be 54 meters. It's falling, so it's going to be a negative 54 meters. Negative 54 meters is going to be equal to V0, which is 0 times time, plus 1/2 times negative 9.8 meters per second squared. I should move that over. Times time squared. All right, this goes away, just like before. 0 times anything is 0. 0 times t is 0. So I get negative 54 is going to be equal to negative 4.9. That negative 4.9 is 1/2 times 9.8. It's t squared. So that means that t is going to be, well, t squared is going to be equal to 54 divided by negative 4.9. So negative 54 divided by 4.9, which is going to be equal to, grab a calculator here, negative 54 divided by negative 4.9 is going to be 11.0. And then that's t squared, so what I'm going to do is I'm going to square root both sides. So I get t is equal to the square root of 11. So second square root, which is about 3.3 seconds, 3.32 seconds. So that is my time for both the vertical and the horizontal. All right, so now I can go ahead and put that time in here and get my horizontal distance. So I get change in position is going to be equal to 16 meters per second times 3.32 seconds, which is going to be equal to somewhere in the neighborhood of like 50-ish. 16 times 3.32, 53.1. 53.1 meters. So that's the answer to my first question. Let's go ahead and put that into my table. 53.1 meters. All right, that was the answer to part A. Part B, a little more difficult. Part B, we're looking for the V final, and keep in mind we've got three final velocities to deal with. We've got V final in the y direction, or the vertical direction. We've got V final in the x direction, which is the horizontal direction. And then we've got a V final combined. That's what this is. This is V final combined. But in order to find V final combined, we need both the vertical and the horizontal. Well, we've got the horizontal. All we have to do is find the vertical, and then we can find the combined. And I'll show you how to combine those in a minute. So let's go ahead and find V final in the vertical direction. So V final, y direction, is going to be equal to V0 plus AT, all in the vertical direction. So we've got V final in the y direction is going to be equal to 0. So that comes from here, my vertical direction, plus a, which is negative 9.8 meters per second squared, times the time, which is going to be 3.32 seconds. So that means V final in the vertical direction is going to be negative 9.8 times 3.32, enter, and we get negative 32.54, or we'll just go to negative 32.5. So negative 32.5 meters per second. So negative 32.5 meters per second. That gives us our vertical and our horizontal. So what's going on here is, let me go ahead and draw a picture of this. Actually, I can put it up here. The stone gets kicked and it's following this path here, and right here is where we're talking about V final, looking for the final velocity. Let me draw that a little better. The final velocity at that spot. Let's go with medium point. Final velocity right at this spot here. Well, if I blow this up, what I'm going to find is that this velocity is at an angle. So this is V final combined. And it's got a vertical component, which is that negative 32.5 meters per second. So this is VF in the vertical direction, and it's got a horizontal component, VFX, which is this 16 meters per second in the horizontal direction, right there. So this is essentially a right triangle. So I'd call up Pythagoras, and Pythagoras would tell me that a squared plus b squared equals c squared. So what I would take is my VFY, which is negative 32.5, and I'd square that, plus the VFX in the horizontal direction, which is 16, and I'd square that, and that's going to give me c squared. So that means, let's grab a calculator. Let's go ahead and take my answer and square it, plus, oops, that's minus, plus 16 squared. Hit enter. That gives me 1,314.6. So c squared is equal to 1,314.6. So that means that I'm going to square root both sides to get c. C is going to be equal to, again, I want to square root this, so second square root, second answer. There we go. 36 meters per second, or 36.3. 36.3 meters per second. That's the answer to part B, or well, I guess it's labeled C here, part B, because there's only two parts, A and B. That's it. Some key things you want to remember are that in the vertical direction, V0 is 0, and acceleration is negative 9.8. That's almost always true. Actually, it is true, unless this thing is thrown vertically. And that the time is the same for both, and that in the horizontal direction, A is 0.